This video is on atomic radius. Atomic radius is a measure or distance from the center of the nucleus of an element to the edge of its outermost electron orbital, basically measuring the size of an element or atom. As you move from left to right on a periodic table, the radius decreases, and as you move from top to bottom, which is down, the radius increases. The radius decreases as you move right because, as you move right, the amount of protons increase, pulling the electrons closer to the center of the atom. The radius increases as you move down the periodic table because, as you move down the rows, with each additional row, there is another electron orbital, increasing the size of the radius, as you can see with the difference between oxygen and sulfur. This is the model for oxygen, and this is the model for sulfur. Each complete orbital shields the valence electrons, which are the electrons of the outermost shell, blocking them from the attractive force of the increased amount of protons. For oxygen, the valence electrons are these ones because they're in the outermost shell, while these two are not valence electrons. For sulfur, these ones here are the valence electrons because they're in the outermost shell. Because this inner shell of oxygen is a complete shell, it's shielding the outer shell from the attractive force of the protons in the nucleus of the oxygen. Although there is more protons, which would make it seem like the radius would be smaller, the two inner shells are shielding the outer shell from the attractive force of the proton. So because there are 3 electron shells in sulfur rather than the 2 electron shells in oxygen, sulfur has a bigger atomic radius. There is no difference in electron shielding when moving right on the periodic table because throughout the same period, all the electrons are in the same energy level. Therefore, electron shielding is not in effect while moving right on the periodic table, and the size of the atoms decrease. You can see this when looking at nitrogen and oxygen. As you can see on the periodic table, oxygen has 1 more proton than nitrogen does, which means it has a greater force pulling the electrons in towards the center. Nitrogen has no difference in electron shielding than oxygen because nitrogen only has 1 complete shell, just like oxygen, which only has 1 complete shell. The difference is oxygen has 1 more proton than nitrogen does, so the attractive force is much greater in oxygen, pulling the electrons closer, reducing the size of the atom. Now you try to determine which one has a larger radius. Look at these 2 elements, lithium and sodium. Do you know which one is bigger? I'll give you a couple seconds to figure it out. Okay, if you look at the periodic table, you could tell that sodium has a bigger atomic radius than lithium because it's below it on the table. Here's why. Sodium is bigger because it has 1 more electron shell than lithium does. Sodium has 3 shells, while lithium only has 2. Because sodium has 1 more shell than lithium does, it makes the atomic radius greater. Here's one last question for you. Do you know which atomic radius is bigger between sulfur and chlorine? I'll give you a couple seconds to figure that out. Okay. Sulfur has a greater atomic radius than chlorine does because it is further left on the periodic table. Remember, there is no difference in electron shielding between sulfur and chlorine because sulfur has 2 shells shielding the outer shell, while chlorine also has 2 shells shielding the outer shell. The only difference is the amount of protons. And as you can see in the periodic table, chlorine has 1 more proton than sulfur does, which means the force on the electrons is greater, bringing the electrons closer to the center of the atom. This video was on atomic radius, and I hope you learned how to tell the difference between different atoms on the periodic table and their radius sizes.